Good day, students. In our last class, we looked at the squares and square roots of perfect squares. Now, this will help us in today's class, which is on surds. So today, what is a surd? Before we go into surd, we need to look at something. We need to look at what a rational and an irrational number is. Rational and irrational number. Alright, because understanding what a rational and an irrational number is will help us in solving questions on surds. Now, a rational number is a number whose exact values are known, while an irrational number is a number that the exact value cannot be determined except by approximation. For example, 7/2, we know this. If I do 7/2, I will have an exact number, which is 3.5. This is rational. All integers are rational. What are integers? Example 1, 2, 3, 4, continuously. They are rational numbers. So what's an irrational number? I told you that an irrational number you approximate. You don't know the exact value, so you need to approximate. For example, the value of pi. We know pi those days to be what? 22/7. If you divide this, it will never end. So usually you approximate. They tell you approximate it to be what? 3.142. Because the value cannot be gotten exact, it is now approximated. It makes it an irrational number. So we are going to be looking at how to reduce surds to both whole number, whole integers, and also irrational numbers. Now, what is a surd? A surd is the root. A surd is the root of a rational number. It is the root of a rational number, but a surd in itself is irrational. A surd is an irrational number. A surd is the root of a rational number, but if you determine the root of that rational number, it's going to give you an irrational number. That is what a surd is. So our purpose for this class, I told you that in my channel, I make mathematics easy. So the purpose in this class is to see how to reduce a surd to the lowest form. That is its basic form. Now, what is the basic form of a surd? A surd is the root of a rational number. For example, if the rational number is n, this is a surd. Another example, we can have root 2. This is a surd. We can have root 5. It is a surd. We can have root 7. This is also a surd. Now, if you are given, for example, I'm giving root 16. Root 16 gives me what? 4. I've been able to convert this one from the root of 16 to 4. This becomes an integer. It is no longer a surd. So when solving surd question, we'll try to see if it can be removed from surds to basic integers. If it is not possible, we have to reduce the surd to the lowest form. If an example is given to us as root 8. Now this root 8, it is a surd, because if I take the square root of 8, I can't get an exact value. I'm going to get an approximation. But I can further reduce root 8 to what? Remember what we did in our last class. In our last class, we looked at perfect squares. I can get a perfect square from 8, which is 4 times 2. Now, this is square root of 4 times square root of 2. We are going to explain it in my next section, which is the rules of surds. Now, Root of 4 is what? 2. I can't determine the root of 2 except I punch my calculator, because it's going to give me a number that we don't know the exact value, otherwise called an irrational number. But we've been able to reduce root 8 to what? 2 root 2, because we determined what a perfect square is in root 8, which is 4 multiplied by 2. So we reduce this. Alright, now let's look at the rules of surd. The first rule, rule 1, is the multiplication rule. If I am given root a times b, because it is multiplication, I can separate this. I can write it as root a times root b. This is the first rule of surd. Rule 2, the division rule. If I'm given root a over b, I can write it as root a over root b. Please follow me carefully, because all this we are going to apply it when we start taking examples in surds. Example 3, the addition rule. Root a plus root b. It is not equal to, please take note, it is not equal to root a plus b. Please take note of this. When it is addition or subtraction, it is not equal to, you cannot separate them. Rule 4, root a minus root b is not equal to root a minus b. Please take note of these 4 rules of surds, because we are going to apply them when we start solving our examples in surds. Let me also explain what similar surds are, because it's going to help us in our operations in surds. Similar surds are surds that have the same integers in the root. Let's say I'm given a root n plus b root n. Now, look at this. Because this and this have the same integer n inside the root sign, they are similar. So I can then decide to write it as what? I'll factorize root n out into a plus b. It's going to help us in simplifying surds. Take note. A root n and n root b are not similar. Why are they not similar? Because n and b are 2 different integers. Look at this first one, n. They are both inside the root. They are similar because you have the same integers inside the root. But for this one, n is inside the root, while for here we have b inside the root. They are not similar. Alright, let's take some examples in surds. Alright, example 1. Simplify root 80. Alright, look at this. We are giving root 80. Solution. In simplification of surds, the first thing that needs to come to your mind is it possible for me to have a perfect square inside the surd that is given to me? Remember, I explained the perfect square in our last class. Now, let's look at 80. Can I have a perfect square in 80 will be my first question. This is what you do in getting this. Let me get the factors of 80 out. I know that 80 can be 80 times 1. 80 can be 40 times 2. Any perfect square here? No. 80 can be 20 times 4. Is there any perfect square here? No. 80 can also be 16 times 5. Yes, I have a perfect square here, 16, which is a perfect square. Then I have 5. So in my solution, I'll write my root 80 to be equal to what? Root 16 times 5. Now 16 times 5 is still 80, so this is the same as this. Remember, in one of our rules of surd, I can decide to write it as what? Root 16 times root 5. What is root 16? Because it's a perfect square, the square root of 16 is what? 4. Root 5 is not known, but we've reduced 80 to its simplest basic form, which is 4 root 5. I'm sure this example is clear enough. You can see how we got out the factors of 80 to determine the perfect square there. All right, we'll take another example. All right, example 2 says simplify the square root of 108. Now, I look at my 108. I need to reduce my 108 to have a perfect square in it. My root 108, you have to list out your factors of 108, but I know by my solving that 108, I have 36 times 3. 3 times 6 is 18. 3 times 3, 9 plus the 1, 10. So 108 is 36 times 3. If you list out your factors, you are going to get this. Why am I picking this? Because I know that 36 is a perfect square. Now, I can reduce this further to what? Root 36 times root 3. What is square root of 36 is what? 6 root 3. We've succeeded in reducing root 108 to 6 root 3. We are going to take final example in reduction of surds. Example 3 says simplify square root of 75. Just as we've done in the other questions, all you have to do is to reduce 75 to the square root of a perfect square times another rational number. Now 75, I know it is the same thing as 25 times 3. If I multiply 25 times 3, I will get 75. I'm picking 25 because I know 25 is a perfect square. So I apply the rules of surds, which says if I have two numbers multiplying themselves, I can separate them. 25 times square root of 3. The square root of 25 is what? 5. And then root 3 is not easily gotten, so I will leave it as this. So I've reduced my root 75 to 5 root 3. All right. Now we'll be taking examples in multiplication and division of surds. And then we'll also do examples in addition and subtraction of surds.